Hello and welcome to Shape the System, where we find and tell the stories that help people to rethink the way the world works. We interview people from all over the world who are helping to change our systems for the better. Shape the System is an independent podcast with support from KPMG High Growth Ventures, who help ambitious founders and their teams scale up for success. More about KPMG High Growth Ventures after the interview. We hope you enjoy this episode.
Hello, welcome back, everyone. Getting up to episode 82, I think, or 83 by the time this goes out, nearing 100 episodes, which I'm actually quite happy about. I haven't really thought about that until the other day. Anyway, today we're going to be talking all about, I guess, decentralized and centralized production of, I don't know if food's not the right word, but the things that typically might find in a grocery store. And we're going to be talking to Wayne McIntyre from Relocalize. And before we dive into the problem space and how this works today and how you guys are tackling it, Wayne, just introduce yourself. Where are you? Where are you coming from? And I want to understand how you arrived to be working on this problem from a personal perspective, and then we'll go from there.
Well, great to be here, Vincent. Appreciate the invitation and happy to help you get closer to your 100 episodes here. You got a great podcast. I really enjoy it. And so myself, I'm a co-founder of a startup called Relocalize. I'm the CEO as well. And I'm a lifelong tech person. I've been in tech since the dot-com boom, experienced the bust and been in many startups since. And my journey has really been, it started actually, believe it or not, as a lawyer. Please don't hold it against me, working in corporate finance down in the United States. And, very quickly realized that all the fun was being had on the other side of the table. Right. All the excitement was there. And so I made that jump out of law, walked away from a nice big paycheck. And I've spent the last 20 some odd years working primarily for technology startups in leadership roles, all kinds of different roles, learning all types of different markets. And the one thing that, I always have done in my life is pursue learning. And I'm really curious. I like to do new things. But I've always separated that learning between personal passions and professional many times. So, I might be working for a biotechnology startup, but then on the side, I'm very involved in decarbonization, environmental issues, and these were always separate. And so the journey that got me here was actually an opportunity finally, I think, to say, why am I keeping these things separate? How do we start a business where I can get up every day and pursue my personal passions as well as my business objectives? And that's Relocalize.
Yeah. And then specifically Relocalize itself, like you said, you're a co-founder. Is it the kind of classic sat over a kitchen table or a cafe and sketch something out? Like, how was it that you thought, okay, we've found an opportunity? I just want to understand kind of the context that actually landed you into Relocalize. And I know no one yet knows what Relocalize is, so I'm going to be talking in ambiguous terms, but trying to understand kind of the specifics, how that happened.
Let's see, I guess this would be about 2010. I was working for a food security not-for-profit, or on the board anyways, not really work on the side. And it really was, like, again, a passion project. And really, it opened my eyes to food security issues. It opened my eyes to sustainability issues around food and just the complexity and the problems with our food system. This is something that sat with me for really more than a decade. And, I've constantly been looking for business models and opportunities to really have impact in that area. And I kicked a lot of tires, other people's companies. Maybe I could join and help my own ideas, napkins and, Excel spreadsheets. And that process really came to a head about 4 years ago when I started really putting pen to paper on a business plan and a business model for actually a vertical farming business. And when I really started digging into it, my challenge was, how do I get the economics to work? Right. And I could see how they'll work in the future, right? As food gets more expensive, as, we start to internalize some externalities like carbon. There really is a path, I think, a great path for vertical farming in the future. But I was really struggling with the present. And that really set me in a new direction to say, all right, well, I need a place where I can have a business that delivers for our food system, delivers products, food and beverage products in a way that's sustainable, both economically and environmentally. And just by chance, I, met someone who was working in the packaged ice industry And that took me down a path of packaged ice and then beverage. And I finally, something just twigged there. I took some of these business models I've been playing with for vertical farming and co-locating production of fresh foods with distribution and doing a bunch of interesting things. And I plugged in the same data, but for a food and beverage product made of water, and suddenly everything worked. And that was really
Interesting.
Relocalize, an aha moment where, wow, we could cut carbon costs and actually have a business that could scale today, not 10 years from now or 5 years from now.
Yeah, that's super interesting. And I want to get to ice later because there's going to be a lot of talk about ice of the liquid kind. And so I want to I think it's a really good segue to actually some of the kind of the status quo around food and beverage. And I kind of, it's such a broad and nebulous term. I think it's firstly important that we're talking specifically about what we're referring to here. And I'm going to have a crack, but I want you to correct me on this. When we think of going into a store, maybe a grocery store or maybe a large kind of big box store like a Costco or something like that, there's a whole bunch of things that are on the shelf that we would either eat that are completely prepackaged or that we might drink, right? So food and beverage is this umbrella. And the nature of how that food and beverage ends up on that shelf is the thing I just want to understand initially to understand our status quo. So help me understand the kind of the parties that are in that, the participants and the moving parts, and what it looks like today to be able to walk into a Costco and pull out a 20-gallon or 20-litre, depending what country you're in, thing of water. What does that actually look like?
If you look at food, really any type of food or beverage product, it could be a lettuce, it could be a tomato, it could be a bottle of water, it could be a package of ice, it could be a box of cereal. Ultimately, they all start their journey in the same way. There's an ingredient or a set of ingredients. Those ingredients need to be produced. Very often, that could be a farm for, say, a lettuce product, or if it's a soy milk, for example, a dairy alternative soy milk, it's soybeans in the field. Now, those ingredients now have to go to a point where they're processed. And, there are trucks, there's a whole bunch of steps involved in that process. If it's lettuce, maybe it just needs to be washed, right? And the good lettuce separated from the bad lettuce and then packaged. If it's a soy milk, well, those beans need to be processed into an ingredient that can then be added to that dairy product. But each one of these steps involves trucks, involves multiple different players, lots of complexity. So you go from that point of the ingredients to the point of, I guess, processing. And then there may be multiple steps in that journey. So there may be, 5 different ingredients. There may, they're all, the complexity varies from product to product. But each one of those steps involves trucks, involves transportation, involves supply chain and complexity, until finally you have a finished product. And so if it's a soy milk, for example, that finished product is now, the ingredients went in, it's been made, it's been packaged. Now it goes to a distribution center. Mm-hmm. And the distribution centers are what serves all the different food retailers. Also, they serve, direct delivery and other, channels to get to that customer. And those products go from the distribution center. They're collected there. The average grocery store has 37,000 different individual items. They may come from multiple distribution centers in some cases. And then they go on trucks, either to the stores where a customer will pick them up, or sometimes they can go to a fulfillment center or be delivered directly to the customer from there. So a whole lot of steps, a whole lot of different players, and a whole lot of trucks. That's really what it boils down to.
Right. And so if you're thinking about this, I'm going to come to economic terms, but I want to talk purely about environmental terms initially. The largest kind of problem in all of this is just how much we have to move so much stuff around to make the whole thing work. Is that kind of the fundamental part of it? Or is there some other, thing like losses and things like this that also occur as a result of the current way the system works?
Well, at every step in this process, there are losses. There's food waste. And for some food waste product categories, it can go up to almost 50%, right, before it ever gets to the consumer. And so you have losses all the way through the process. But I think the biggest problem is the system itself, right? So I just described one chain, or 2 chains. There are thousands, tens of thousands of these individual supply chains that all converge on a distribution center. There are thousands of different companies, and there's so much complexity that when you look at this system and say, all right, you know what? I'd like to get rid of trucks. Right? How do I get rid of trucks? How the heck do you do that when there's so many people involved and all I control is my little piece? right? And this is why our food system is really so difficult to fix, because whether it's you're trying to address the waste problem, or whether you're trying to address the fact that, our food system produces more than 3 gigatons of CO2 alone, just in that processing, retailing, logistics portion of that system. There's just so much waste, there's so much carbon and so many problems. But when you go to fix it, basically you have to pick one link out of that chain and say, okay, this is going to be my link. But you can't change the chain. And this was really where, when we started looking at what we wanted to do, which is ultimately to get food off of trucks and beverages off of trucks, starting with products made of water, we looked and said, well, the only way we can do this is to take complete control of that system. We need to own that chain. Actually, even better, we need to get rid of the entire chain. And that was really the birth of Relocalize. And our vision for Relocalize right from the beginning was, whether it's a tomato or whether it's a package of ice, how do we make something at that distribution center and take that whole value chain right from the beginning and collapse it, compress it, control it, and put it right at that distribution center so all that complexity goes away.
Yeah, I understand. Okay, and so if you look at distribution centers, now I think there's 2 types, right? There's distribution centers that might serve a multitude, but there are large enough organizations that essentially run their own distribution centers. But either way, the function is a whole bunch of things come from a whole bunch of places, and they then flow out to the actual store that might be right next to the distribution center, or it might be, I think in the case of Walmart, I did a little bit of research, they might have, 4,000 stores, but have 400 distribution centers that service those 4,000 stores. So either way, this distribution to retailer model and distribution to customer model is not necessarily broken, or it might be hard to solve for that. But solving for how do you get the stuff to distribution is really the part of the value chain that you're focused on.
Absolutely. And that's the part where, the distribution journey is actually one of the more efficient journeys. So they are multiple product. It's called a mixed load, right? So you can optimize that load for both volume. So you're full from a volume perspective, and also full from a weight perspective at the same time by combining heavy products with high volume products. Unlike a trip from, say, a beverage truck. A beverage truck is full from a weight perspective, but empty from a volume perspective, and it may be traveling a relatively large distance to get there. These distribution journeys tend to be short. They tend to be much more efficient than the upstream supply chain journeys on trucks. And ultimately, they're controlled often in this day and age by the distributor, or in the retail grocery world. Most large grocery chains, 100 stores or more, have their own distribution centers today. So it's all part of that same system. So that means you really can make a change because it's all in one place and all controlled by one entity.
Got it. Understood. Okay, cool. So we've got all the context. We understand there's an economic challenge as well. Anything that results in multiple people driving multiple things in multiple places with a bunch of infrastructure obviously has an economic challenge as well. So if you kind of a lay person understanding what we've just talked about in the last 13 minutes and 17 seconds, you'd say, oh, great, well, the obvious thing to do is to make the stuff where it's being distributed from. So I want to understand, firstly, why this hasn't been kind of adopted already in the mainstream. What's changing or has changed that means that now it's becoming relevant to do it? Is it externalities, or is it technologies, or is it just status quo that needs to change? What's changing?
The biggest difference today is technology and the cost of technology, things like robotics. But before we talk about that, let me take a step back to how we got to where we are, right?
Please.
So this food system was built in an environment where, we believe that scale was always better. Economies of scale. That's the only way to drive down costs, right? We believed that externalities didn't come with a cost. It didn't matter if we polluted. It didn't matter, if we used a lot of trucks, because ultimately those externalities were not going to be priced in. We didn't have to have any responsibility for them. And it was also assuming that there was going to be endless cheap labor, right? And our whole system was built around these conventional assumptions. Now, I think what we're doing and what we've discovered is, hey, the time is actually right where we can actually break that model a little bit. So for example, for products that are heavy, so products made of water are extremely heavy, very expensive to transport on a truck. When you decentralize production capital, for example, you put a micro factory at a distribution center, it's going to be a little bit less efficient, right? You have more machines in more places to maintain those machines. It's going to be a little bit less efficient, but right now, because the cost of robotics has come down so much, because the capabilities of the industrial Internet of Things are so powerful with AI. I used to run a predictive analytics company. The things we can do for predictive maintenance are so powerful that actually we're at a point where we can put those microfactories at a distribution center and not be that more inefficient than a big factory, because when we're there, we don't need trucks. So they cost money. We don't need land. We're just sitting on the distribution center, a little bit of distribution center parking lot. We actually, this labor assumption, because we're using automation, we can still centralize our people in a command and control center and run that factory from a distance. So we get all the benefits of centralized labor, and sometimes that, centralized with technology instead of with actual physical proximity. And that it gets that labor efficiency. And right now, when we're talking about at least carbon, when we're talking about products made of water, they're so heavy and expensive to ship that cost also equals carbon. So, when we say, hey, we're going to reduce your carbon footprint of trucking, eliminate middle mile transportation, you don't need to, have any of those trucks. It could be a 90% carbon savings. That's also a 90% fuel savings, right?
Right.
So it really, for the right products, right now, it's possible to make it work even without internalizing those externalities. Once you start internalizing those externalities, the economics are actually really quite powerful. And then we can move beyond just, say, heavy products to other types of products.
Yeah. And there's something interesting in this that I think, and I was kind of leading you towards it insofar as, the technology and automation. I think in the old world, and I'm talking not 20 or 30 years ago, I don't know what old is anymore, but let's go with 30 years ago, the only way to create efficiency in some form of factory was to have a very large factory, right? Because of the cost of labor and the cost of capital and the cost of land, essentially. But if you take kind of Tesla's battery pack as a kind of a parallel or simile here, what they've essentially done is said, we can create one Powerwall and produce it for under a certain economic model, but then we can put 4 million of them end to end and create a battery pack big enough to power a city. And it's the same bit of kit that's just, daisy chained essentially. And I think there's some similarities here in how you're thinking about, the mechanization and the automation to produce a particular object like ice, for example, which we'll talk about in a sec, insofar as you could have a huge factory right in the middle of Nebraska that's producing all of the ice and then sending it everywhere. Or you could work out how to have a small factory and be good at creating multiple factories. And the economics comes from being good at replicating a small factory rather than building one large factory. Is that kind of where the tipping point's coming from?
That is. It's a big part of it. And I left out probably the most important aspect too, though, which is automation does not mean autonomy, right? To be autonomous is quite different than being automated. And, my CTO, our CTO, he's been in the automotive industry for many years. He's seen the evolution of the first industrial robots in the automotive industry to where we are now. And the big difference is everybody's still being held back by their dogma. There are always people at the factories. So it doesn't matter which robotics company you're talking about. No robot can be recovered remotely. They cannot be recovered remotely. Why? They've never needed to. Right. And so all this. So,
they've always been at the factory.
And to be autonomous, you need to be able to do it. And this is really where technology has reached a point where we can layer software and hardware solutions on top of, what would be an automated type of system, and we can make it autonomous. And that's really the tipping point, because without that autonomy, now you're going to have a physical labor force in 1,000 different places instead of just in that one place, right? And our vision would be, if you're going to build a network of microfactories across North America and then ultimately the world that are producing, as a network instead of producing as an individual centralized factory, you need a high level of autonomy. And that's really, I think, the AI, automation, robotics, the cost, all of these things have come together really to create this opportunity right now, which didn't exist 10 years ago, 5 years ago even.
Yeah, as I was saying, 30 years feels old in this context. So I want to get to some of specifically how Relocalize or Relo, as I've been saying, finding it in different places, does this. I just want to talk specifically about the product ice, because you've kind of started with ice and you've talked about water before. Let's just drill into that for a little bit, and then we're going to talk a little bit about specifically how you reach these high levels of autonomy and what that actually means.
So the ice is an interesting product. One, it is one of the products that's the biggest hassle to ship. It's one of the most expensive products to ship. It's extremely heavy. Believe it or not, it's relatively high shrink or high waste. It's damaged in shipping and damaged in handling. And it's also a market that is unique in that it's dominated by geographic monopolists. So I live in Quebec in Canada. There is one producer of ice here. They serve the entire province, which is,
huge.
Bigger than the next four largest countries in Europe, Europe combined here, and they serve it from one factory. Right? You go down to Florida, which is one of the largest ice markets in the world. They have multiple factories. They have four big ones and a few smaller ones, but that supplier there's only one supplier for that whole state, right? And as a result, there's been very little evolution. Ice always looks the same. Ice, they are not innovating. They're not changing what they do. What they're doing is centralizing, scaling more and more, buying up the mom and pops, building this monopoly. And now they have these monopolies and they're just stagnant, frankly. And so if you're going to pick a market to enter, if you go into beverage, there's some pretty big players there that have some pretty sharp elbows, right? And, it's a very competitive space. If you're going to pick a market where you can make a difference, pick a market where, they don't have the same market power in terms of being able to threaten to pull Pepsi or Coke off of a shelf. Mm. They don't have the same innovation that you see in other packaged goods spaces. And it's a surprisingly large market. Believe it or not, it's more than an $8 billion market in North America. And so really ice was a strategic choice. We could invent actually a better way of making ice, the first new ice making technology in many years that helped us in our miniaturization or making it micro. But also it's really those market dynamics where, if we can go to a supplier and say, hey, you're dealing with a monopolist, or a grocer and say, you're dealing with a monopolist, how would you like to have another option? And actually, how would you like it to be your own factory, dedicated supply just for you with a differentiated product? And by the way, it's cheaper and greener too. It's a pretty easy sell, and you don't have to deal with those sharp elbows I was talking about earlier.
Yeah, I find it. It is a fascinating product. I think it's one of these things that reminds me. I feel like, and this might sound like an odd tangent, but bear with me. When there's an opportunity in a market when you can go into any city in the world and talk about that thing, and people will resonate. Like stand-up comedians can go into any city in the world and make jokes about cabs, taxis, and this is back pre-Uber, and everyone will understand those jokes. And you're like, clearly there's an opportunity there because there's an incumbent truth there. And I feel like ice is, in some respects, there's a parallel here, which is it doesn't matter where you buy a bag of ice, you're literally buying exactly the same product. It's the same size, it's packaged exactly the same way, and it's kind of sitting in some, in Australia at least, some outside bench thing that, you have to get the lock from the guy inside the store.
Yeah.
And it's a hilarious product in some way, in that it's so standardized and you wouldn't think that there's another way to do it. Just in terms of the economics of it, though, is if you think about a can of Coke, my understanding is that 90% of the cost of a can of Coke is in the marketing and 10% is in the product. But if you think about a bag of ice, like how would you break it down? What is the cost of it in terms of the logistics and the water and the actual manufacture and whatever other related costs? What does that look like?
So for a commodity product like packaged ice, there's no marketing, right? So there's no branding to invest in. And so the biggest costs are the same thing as they would be for a no-name brand cola. Right. So we won't talk about Coca-Cola, but a no-name brand cola, its biggest costs are trucking and then packaging and then the ingredients. Right. And for ice, it's exactly the same. Only the ingredient is water. It's a very simple input supply chain here, but it's trucking and packaging. Right. And so when we looked at this market, what got us really excited is when we look at the cost of that trucking. Right. It gets exciting. And it's also the same for tomatoes, by the way. So a tomato is energy, water, some nutrients, right? And then you package it up. Ice is exactly the same. And I would love it to be tomatoes, to be honest, because I really started this journey on the vertical farming side. I want to feed people. I don't just want to make the drinks cold, to be honest. But we need to take the opportunity where it is now to prove that it works. And the difference between the tomato and the bag of ice is all about throughput. How much, it takes time to grow a tomato, right? And what's different between those two things is they're both just made up of water and energy, really, for the most part. But we can make an ice or a beverage at massive scale at a very small footprint. I can serve 100 stores at a 1,200 feet. Square feet of space, right? And that's a huge difference. And we can do it in a way that is very capital efficient. And that's really why we started with that ice opportunity for that reason.
Yeah. And let's dive into that a little bit, because I think, like, I'm curious about trying to understand, you've right up front sort of said you can stick a shipping container size thing in there. What's actually happening in the shipping container? Like, help understand, what do you plug it into the water mains?
So all of the jobs that would happen in the traditional large factory have to happen in the small one, right? So, we're talking about processing, production, food safety, packaging, storage, and then ultimately, preparation to ship, and then it goes off the dock. And so all we've done is take all those things, we've shrunk it down to what we call micro scale. For us, micro industrial scale means it's still big enough that we can serve in multiple stores. So there's enough centralization that we can, get a return on our capital, like those robots and, packaging systems and other things that we have to package into that box. But it's small enough that it, can serve a local market. And that's really the secret. So it's a same thing as a big factory, made small, but we have to actually overcome some other challenges. We have to do it without people, right? And for the most part, we're trying to do it on demand. Because when you produce on demand, you don't need to have cold storage warehousing. You don't need to have any warehousing. That saves, that warehousing comes with an environmental and economic cost, but also all the touches that go with it. So really, we do all the things a regular factory does, but we do it on demand and we do it without people, which is, as you can imagine, a pretty big challenge, right?
Yeah. And so I know that some of this is the secret sauce, so pull me up where you don't want to go into it. But let's say we've got one of these ice producing Relocalize magic machines sitting in the car park of a distribution center that has some tied, retail outlets, but potentially has some external retail outlets as well, call it 100. In the reality, what's happening? Are they putting in a weekly order for a certain amount of ice and there's a throughput that relates to that? Or are they placing an order somewhere that says, no worries, your ice will be ready? What's the throughput of the machine? Like, help me understand kind of what it looks like.
So a typical distribution center, let's say, serves 100 stores, right? And, they have pretty predictable demand for a product like packaged ice. It's, it's pretty, they know what's coming. They only have one supplier, right? So it's not like we've got, different lettuces or different tomatoes coming from different places. They have one supplier and they pretty much know how much ice they need in any given week or even down to the day for the most part. And so what we, essentially with us, we basically say, we're going to meet 100% of your demand. We're going to do it ideally, in most cases, 100% on demand. And you just come and get it when you need it. It'll be ready for you, right? What we ask from the retailer is, can you give us some space, right? Because we want to be right at the DC, not near. Because near, you still need to get a truck. You still have all these touches. You need to load and dwell. By being on site, what that allows us to do is go from 4 to 6 touches to 1 touch. Because near means not a lot of food miles, but it means the same level of complexity. When we're there, they unload that microfactory just like a truck, goes right onto a distribution vehicle, and it's gone, right? And so that's where you get the most impact from being right at that DC, right? And so the way we get to that, and there's no real secret sauce here. I'm happy to walk you through it. It's quite clear. It's, where there is equipment that works reasonably well and is reasonably small, we buy it, and then we put our hardware and software around it to make it autonomous. So a packaging system is a good example. We're not going to invent a new vacuum packaging machine. We'll buy a vacuuming system from someone else. Package forming system. We'll buy those components, but then we wrap our own hardware and software around them to make them autonomous. When we're talking about things like we use articulated robotic arms. We've got a great partner in ABB Robotics. They've been fantastic, very reliable, very dependable type of equipment. But ultimately, robotic arms are almost a commodity at this point, right? So we're not going to make that. But all the tooling that goes around it, all the software, end of arm tools, all that becomes part of us as well. And so this is really, it's all the different. It's just like what you imagine. But what's unique is you need a control system that you can run from a distance. You need to be able to predict when failures come, manage your process from a distance, and ultimately you have to modify as much of that equipment, none of which is designed for autonomy, to make it autonomous. And where it doesn't exist, we have to build it ourselves. So our ice making system, we had to invent and build ourselves because there just was no technology that could do what we needed to do. So we had to build that from the ground up.
Yeah. And oh God, I've got so many questions. If I'm going to walk inside, I'm trying to create a visual for people. If I'm trying to walk inside one of these things, I'm kind of going to see a miniaturized version of what you would see in a large factory, which is there's water comes in one area. There's a black box, essentially, this thing you created that turns that water into a nice product. It then passes it into something that will package it, and then it will put it into a place where it can be rapidly picked up. And at some point, there's some sort of measurement that says, I'm currently full, so I'm going to stop making. And then the next time a truck turns up and says it goes, great, I'll get a bit more. I'm assuming that whole unit is refrigerated so that ice can continue to survive in that environment. But other than that, there's nothing happening external to that box. Have I kind of got it?
Yeah, you really you nailed it there, Vincent. And it's important for us that, while we're producing, we call it on demand, we need a buffer, right? And so really what we are doing is producing a truckload worth of product and storing it. So there is a little bit of storage there. And that's just because we can't afford to let down our customers. And believe it or not, packaged ice is really important in the southern US in particular. If you're a convenience store retailer or a grocery retailer and there isn't ice there, this is an event that not just involves the loss of a sale, it actually involves the loss of long-term customer value. You do that a couple of times and your customer will find another place because they, when they want that ice, they need that ice now. And when they go there and it's not there, it's very frustrating. They're actually angry. And it's not just about the loss of a sale. So, it's really, so we need that buffer. But yeah, it's just like you imagine. You produce, you package, you go through some, food safety processes, and then you have a little storage component. And for us, actually, each one of those things happens in a separate container. There's a production. It's a 40-foot high cube standard C container. One is where the ice is made, one is where it's processed and packaged, and the other one is where it's stored. It's just that simple.
And the robots, the arms, the ABB stuff, just move it between those units, essentially? Well, those units are all connected?
So they're connected by conveyors, right? And so you'll get, if you go to our website, if your listeners do, they can go to relocalize.com and see this a little bit while we're talking about it, so they can, follow along. But ultimately, the robotic arms are tending a series of basically heat exchangers. So think of them like we're baking bread, a whole bunch of little ovens.
Yeah.
Right. And we bake a batch of ice on each one of them. And then when the ice is ready, the robot transfers that to a conveyor. Conveyor takes it to our packaging and processing area, where it's checked to make sure it's safe, where it's the package is made, then it goes into the package all in one place, in one machine. And then ultimately it goes from there on another conveyor into the storage area, where another robot will pick it up and put it on pallets and prepare it for shipment. It's
fascinating. I love it.
It's again, like you said, all the things you'd see in a full scale factory, but it's just a fraction of the scale.
Yeah, it's super fascinating. And so one of my side tangent questions is, I presume all or some of that environment's quite cold. Do you have to deal with challenges in getting some of these robotics to work in those types of environments? I don't know how many robots are designed to work in the Arctic, but that's kind of what it's going to feel like in at least one part of this container.
Yeah, Vincent, you've identified some secret sauce there, so I'm not going to go into too much detail.
Sure.
Absolutely. The entire system is below zero. Right?
So the whole system. Okay, wow.
Or below freezing for our American listeners, right? And that means that a lot of systems don't like to be at that temperature.
Yeah, absolutely.
Right? And so layered onto this, of course, we have specific techniques and approaches that allow the robots to keep performing even in that cold environment, as well as the other equipment. And because we're really building this to have really the highest possible uptime and throughput, that means that we're also having to actually keep that running all the time without having downtime.
Yeah. No, I'm definitely okay for you not to share exactly how you did it, but I figured that would have been one of the challenges. Is it's fine getting this thing to work, but working in minus 5 degrees or whatever that is for you guys, 20 degrees Fahrenheit, I think probably something like that, sounds like it would have been one of the challenges. So getting beyond ice, you talk quite a bit about food and beverage and, a tomato and the equivalents with water. But even just the next step from ice through to like a, non-marketed, like a white label or, non-branded kind of beverage, like a cola or whatever. How does this translate? Like, are you already 5-6 of the way there with what you've got? Or you think, okay, there's going to be a bunch of different challenges, or how do you see it stepping or evolving to that?
Really, the systems to be really reliable and autonomous, they are product specific, right? And so if you're thinking about moving from ice to beverage, right, the palletizing is pretty standard, right? The control systems and a lot of the software is pretty standard. But the production end of the spectrum is what needs to change. So for us, and when we think about the overall microfactory, we would say that it's probably about 60% proprietary, right? And probably about 60 to 70% food, product agnostic when we talk about the palletizing and at least some of the packaging. A thermoformed package is a thermoformed package, right? You can put lots of different things into it, for example, right? But at the production end of the spectrum, that first container, so there are three, right? There's the packaging and processing, and it's that first container where that's really something that's unique and different for each product. So when we move to beverage, we'll be able to leverage the software, we'll be able to leverage the control systems, we'll be able to leverage a lot of the learning, but we will need to customize the production process and the packaging process to that particular product. So we would see, for beverage, it's actually relatively small compared to the ice. So when we did ice, the challenge with ice was actually that the conventional ice making process, believe it or not, is really quite complex, much more complex than a beverage. And you'd think it would be really easy. We all have fridges, right, that make ice. It is the hotel ice maker, right? And
right.
It's actually the challenge for the packaged ice product is not so much the making of the ice, but then all the downstream processing. And I'll come back to that if you're interested in hearing more about it. But, there are about 5 different pieces of equipment, and we had to completely reinvent the process of how ice was made. It's a different product. It's cubes instead of these rocks. How it's made is quite different. How it's processed is quite different. And it really gives us a massive leg up from efficiency perspective for our competitors when we decentralize. When we flip to beverage, we can use pretty much a smaller conventional type of system for the mixing and for the packaging. So we actually see beverage as an easier technological challenge, but a much bigger market challenge in terms of competition and acceptance, and it's a much more competitive space, right? So I think our approach really is, I think, to say we're working a little bit on our beverage system already. We won't go too far into where we are with that, but ultimately we don't really see this. We see the biggest challenge as overcoming the systemic change and getting retailers, for example, comfortable with the idea of making their beverage products on site in a place where food has never been made before, right? That microfactory we have down there in Florida is the world's first autonomous microfactory. Food is not usually made at a distribution center, right? And food, believe it or not, ice is considered a food by the FDA anyways.
Right, okay.
It's regulated like a food, right? It's,
really?
And actually the International Packaged Ice Association's tagline is "Ice is food."
I guess you put it in your body.
But anyways.
Yeah, that's fascinating. And I kind of get it. I think the other thing that happens just with ice as a product is there's no accounting for taste. It's water, right? And so long as the water is frozen and is cubed into the right size and usable and available, then you've solved the problem. There's no people don't really have brand preference. Ironically and weirdly, there's a lot of brand preference in bottled water. And you'd ask the question as to why hasn't that translated to ice? But maybe, I don't know, maybe the ice manufacturers that exist today are probably partially to blame. So coming back to ice for a second, not the product, but more the economics of this. You've got this micro manufacturing site operating in Florida today. This is kind of where you're up to in the process. Help me understand economically what one of these looks like. And for you and also for the retailer, I'm interested in understanding, this is how much we have to front load into the build of these things, and here's how they turn out economically, and here's actually the business model that we have for these units and the level of utilization they might need. Because I think this is key to going from one of these things to 4,000 of these things, which is probably, where you want to head to next.
You're very much correct, because you need that one system to work. You need the economics to work on that one system. Once you go to a network, there are all kinds of efficiency gains, a whole lot of additional, opportunity for economic return. But in order to get there, you need to be able to work at the unit of one to start, right? So we're not talking about a network here right now. We're talking about the first step is, can we make one work? And again, this is why ICE is so great, because if you talk about, so a typical requirement for a distribution center, say in Florida, would be about 1 million to 1.5 million bags a year, right? These bags sell for about $3, and at the retail level, right? And they're very, our partners are very secretive about how much they pay for that product. But let's just say it's a very big markup. I think most products, including packaged ice is maybe one of the higher margin products out there as well. So there's a pretty nice return for the investor. And so for us, ultimately, we need to be able to build a microfactory and produce enough ice at a cost where, ultimately we can do at least as well as the competing products, right? And that's really hard to do when we're talking about other types of products. But for ice, we're actually in a point where we can actually produce at a lower cost. I think this is why we picked ice. We can really be, with our technology and our approach, we're able to produce at a lower cost. We can actually give them a better product. So it's actual cubes. It's in waterproof packaging. We're certified plastic negative. I don't love offsets, but right now it's our only option. So we pay for offsets. We can put all that value into the product because the trucking is just so expensive. So now we hand that over to the retailer and we say, hey, we're going to give you a benefit right off the mark on how much the wholesale price you're paying is. But what we can also offer you? We can offer you a whole lot of other gains, right? No more warehousing. So an ice retailer may have 20 to 30 truckloads of ice in July in their cold store.
Just sitting there. Yeah.
Every one of those pallets needs to be handled, loaded, unloaded. So, we're at cost on shelf, we can deliver north of 30% cost reduction, cost on shelf for a retailer, and give them sustainability. And this is where then they start, this is the easiest sales pitch I've ever done in my life, ultimately, because, usually sustainability costs more. So how about I give you a better product that, a cube that looks like a Super Bowl commercial, not that chunk of ice frozen together in a bag, in a better form of packaging. It's the best we can do right now, and it'll keep on getting better because we care so much about the impact and sustainability side of things. And it's a dedicated source of supply. So you've had availability problems in the past. Don't worry, it's your own personal factory. So you get all of that supply, and they're able now, I think, to look at that and say, all right, it's ice. I get it. We'll start there. Hopefully we can move, and we expect once they get comfortable with this, they'll move beyond other things, but they are then willing to sign a long-term contract with us. And that's very rare in the retail food industry, long-term contracts, but it is possible to get a longer term type of commitment if, they know what they need, they have a sense of what their supply requirements are, and we can give them so much savings. It's worth saying, okay, you know what, for that level of savings, I'm willing to do something I might not be willing to do normally. And on our end, we're able to do it so efficiently because ultimately we're removing labor, we're removing trucks. We don't pay for land. We don't pay for trucks. We don't pay for truck drivers. We don't have a big head office. We get rid of all of the other types of capital other than production capital completely. And get rid of all of the, at least on-site labor and inefficiency there. We do have of course, our technicians that manage it remotely. This is not a people-less business. But the production asset is. And it gives us the unit economics where we can pay it back. I don't want to get into too much detail on this front, but let's just say it gets into that sort of 12 to 24 month range. And when you start looking at 12 to 24 months for a factory, right, that's a really fast payback, right? So we talk about, often vertical farming numbers are 5, 7, 10-year payback, right? We're talking about, let's say 24 months. This is a place where you can find really good infrastructure financing as well, because our business model is we own and operate them. There's no hassle for that customer. They just unload it, right? And that means it's our factory, we run it, and we need a ton of capital. Of course, VCs don't want to see their money going into infrastructure and CapEx like that. They wanted to go into technology. So what we're able to do with this great payback rate and these great unit economics is separate the investors who want to own the infrastructure, and there are lots of those who really like that type of investment, and those who want the risk and tech. Then it all comes down to that fact that we've removed the biggest costs, right?
Yeah, I find it fascinating. And not only is it a small thing, but it sounds like if you're the full owner operator, then the input costs that you do have of energy and water, things that you factor into the delivery of the unit. So, let's say you're a distributor who's got one of these on site, it needs its own electricity and water, but you factor that in, and that's a price that you then have to manage or whatever. Yeah.
And we have predictability on, unfortunately, water is not very expensive today. Energy is. And so really it goes well with our purpose again, right? Which is because we're investing in, I think, a long-term solution. We're trying to build something that has a big impact. We'll overinvest in efficiency, right? We'll overinvest in packaging sustainability. We'll overinvest as much as we can because we believe overinvesting today and being an ICE allows us to do that and allows us to really live our purpose. And in the long run, this will come into an economic value as well, right?
Yeah. And look, I think the thing that also happens is when you're the operator of the asset, then you care about those things because your economic model is tied up in taking those inefficiencies out of the system. That's literally how you make or grow the profit, rather than saying we don't care about any of those things and someone else will pay for those things at the other end, at the retail end. So I've just had this interview's not live yet, and it probably won't be by the time this goes live, but I've just had an interview with a car manufacturer who are looking at an owner-operator version of a car rather than selling you the car. Because if we sell you the car, we don't really care how inefficient it is because you're paying for it anyway. And by the time it goes off the lot, it doesn't matter to us. But if we operate the car, it forces us to make decisions that drive the efficiency because that's the only way we're going to make money ourselves. Like the incentive structure is fascinating on these things. So for you guys right now, you've got this micro site running. We're talking, middle of 2024 in case people are listening to this later. Next step is to secure some form of investment that allows you to go and run, 5 more pilots or 10. Like what does the scale from here look like? What are you aiming for?
So we launched our first proof of concept system in March, and it's been running, very, very well. Or March of 2023. We learned a lot from that. We really proved the things that could be proven, and the things that didn't work. We learned a lot from that. And so right now we're building that first full scale system. That first full scale system, we raised a seed round not too long ago. We raised $5.8 million of seed funding US, and that's really where right now we're at that point of getting that system out there, putting it into a couple of retailers so we can see it live, proving out the unit economics. And the next step for us then is to say, okay, we now have 2 in the field. How do we get to 100 a year?
Right.
And because this system, the ICE is so much better. Product is so much greener. Retailers are so frustrated with the monopolists they've had to deal with for so long that we are not demand constrained, we believe. We are entirely supply constrained. And that means how quickly can we build these microfactories and put them in the field? And that's really the next phase for us. We're looking to raise a Series A in 2025 to support that kind of growth, because we do believe that ultimately this is, we all talk about disruption, right? It's cliche at this point in the tech world, right? This is a market that really is ripe for disruption. And in so many ways, because not only is it, geographic monopolists, they're very happy where they are, they're order takers, but ultimately they don't have ability to respond very quickly, and they're dependent on scale because they're trucking, right? And so one of the big metrics for truck is essentially how dense are your routes? So how many stops, how many deliveries can you make with that same truck? Route density is the terminology they use in the industry, right? We don't care about route density, but we impact theirs very quickly. We cherry pick their easiest customers, down goes their route density, and their business model breaks. And when their business model breaks, we have to be there to supply those customers now, because if there's no ICE in Florida, we need to be ready to build enough microfactories to be there to supply that demand for people who really need that ICE.
Like the idea of the whole disintermediation of the way ICE is created, which feels like one of those, non-sexy problems. But as you said, if it's an $8 billion market in the US alone, it's an incredibly sexy problem if you're someone who's looking to make capital return. And I think you're right. I think it's hard for an incumbent to respond, because by responding, they're further accelerating they've got the innovator's dilemma essentially operating in this.
Yeah. That's why we love the ice market. And I think beverage has some risk there too, right? I mean, it's a much more complicated, much more competitive market. But if you're a big beverage company, I'm not going to name names, but there's one big beverage company here in Canada. There are 4 production sites across this massive country, right? And, when you talk to the leadership at this production company, they would say, from the company's perspective, that's 3 too many. It should be, ideally, it would be 1, right?
Right.
Maintain control, maintain standardization. And they're so bought into the system, right, that there's nobody thinking about what if we produce hyperlocally. Nobody's even thinking about that. In fact, they find the idea probably offensive, from how do we maintain quality? How do we maintain, it just goes so against what they're doing that I do believe while in ice, it's the perfect place for disruption. I do believe beverage has that same type of profile. It'll just take longer and it'll be a much bigger fight. And so for us, we believe that, we stay with ice and then we move to beverage, but we move to beverage once we have the retailers on our side as our allies, right? They believe it works. They're our allies. They see this new system. They see an opportunity to move up the value chain. And then when you have a beverage, this is a multi-trillion-dollar kind of market around at this scale, right? And from that position of strength, I really hope that there's an opportunity for us to move into that tomato one day. Because ultimately what we want to do is not just produce products that are luxuries, products that are, nice to haves. We want to produce products that actually feed people. They have calories in them one day as well. But in order to get there, we believe the best thing is to actually prove that it's possible. And what better place to do that in ice? And then make a success and then build on that success to, go to that ultimately address the tomato and other products down the line, right?
Wonderful. Well, Wayne, we'll leave it there today. I think you've gone through the entire cycle of it. It was a fascinating journey. And I love catching a founder in a company at exactly this moment, this inflection point. We've done it a few times. We interviewed the great rap guys who've just had their 5th birthday, I think, and similar challenge. They had to build a manufacturing site after proving a thing at a very small scale, and they've gone on to do great things. So I'm super excited to see where you guys get to, and hopefully we're checking back in a year or two and seeing hundreds of these things, or 100 a year, I think, to your words and sharing in your success. So thank you for joining us today, and all the best with where to from here.
Well, thank you, Vincent. It was a pleasure to be here. And, we're always happy to talk about a truck-free future for food. Hopefully we inspire some others, because ultimately Relocalize can't do it alone. And I really do believe that this opportunity, and there are others, I know you've interviewed some of them as well. And sure. I'm really looking forward to there to being 100 companies like us pursuing this opportunity, because at the end of the day, we need to get food off of trucks. We need to decarbonize our food system.
Love it.
We hope you enjoyed this episode of Shape the System. As usual, if you'd like to suggest a guest, someone that you know who's helped change a system for the better, please go to www.shapethesystem.org, click on the top right-hand corner, then click Suggest Guest. Make sure that you click subscribe so that you get the new episode. Shape the System is an independent podcast with support from KPMG High Growth Ventures. Connects founders to the services they need along their journey. Whether you are looking to refine your strategy, mature your finance function, prepare for a capital raise, expand abroad, or simply comply with regulatory requirements, they provide you with the support you need to drive your business forward.